I am Taiwo Adewale Ayomide. I am here to explain more about differentiation. I am here to explain more about differentiation, how to solve a problem under differentiation. We all know that differentiation is under calculus. We all know that differentiation is under calculus. So let's quickly check calculus. That is differentiation. So this is calculus, this is differentiation, this is calculus, this is differentiation. So in calculus today, we want to look at how to differentiate. How to differentiate. How to differentiate. Let's quickly look at a simple example, a typical example under differentiation. Example 1. Let's see. Differentiate with respect to x. Y is equals to x squared. Differentiate with respect to x. Y is equals to x squared. So by solving, we say solution. To solve this problem, the rule will be y plus change in y is equals to x plus change in x. Y plus change in y is equals to x plus change in x. So by solving this problem, our question is y is equals to x squared. The question is y is equals to x squared. So by solving this problem, we are using this rule. This is a rule. So by solving this problem, I will say y plus change in y is equals to this x to respect to x. So x is carrying squared here. This principle will be carrying squared. So I'll be having x plus change in x all squared. Why am I putting squared here? Because the question is having squared. The x to respect to x. This when x is carrying squared. So you put the squared here. Then we'll now say y plus change in y equals to, when you expand these brackets, we have x squared plus 2x change in x plus change in x squared. When you expand this, that is when you expand this, it will be x plus change in x 1 under x plus change in x 2. You can see why, because this bracket is carrying squared, so you have to come back in 2 times. Can we see? So when you multiply the whole of these brackets with the whole of these brackets, we have this. Understood? So then we cannot proceed. Then this y can come to the other side. We now say change in y is equals to x squared plus 2x change in x plus change in x squared. Then if this y comes to the other side, we have minus y. Because it's a positive y, when it comes here, it will become minus y. No, by solving, recall. We now say recall that y is equals to what? Y is equals to x squared. So I will now bring where I'm seeing y, because this y has passed its boundary. What is y looking for in x family? So remove the y and put x squared there, since you are recalling that y is equals to x squared. So now say change in y is equals to x squared plus 2x change in x plus change in x squared minus when y is what? X squared. When y, that is, you recall that y is equals to what? X squared. So this x can take care of this x. This is positive x squared. This is negative x squared. So what we are going to have left is the y, change in y equals to what? Equals to 2x change in x plus change in x squared. There is nothing to do here again than to divide both sides by changing x. So divide both sides by changing x. We have this by changing x, by changing x, by changing x. So this cancel this. This will take care of this. It will remain 1, right? So we'll be left with changing y over changing x equals to what? 2x plus changing x. Then I can apply limits. It will now become lim. Changing x should be equals to what? 0. I will apply limits. This is limits. So I call it lim. Changing x should be equals to what? 0. So therefore, I can now say that changing y over changing x equals to 2x plus limit as shown. It said let all changing x should be 0. So 2x plus what? Changing x now turn to 0. Then we can now say the y, the x equals to 2x plus 0 will give us what? 2x. In our last video, I recall us back to this. As you can see, if y is equals to x squared, then the y dx will be equals to 2x. Thank you.